Hi, I'm Andy, and this is my lesson on recursion in Java. In this lesson, I'll introduce you to recursion, a powerful concept that can help you solve a wide variety of programming problems. Then I'll show you how to write a recursive method so you can see recursion in action. Let's get started. Suppose we're faced with the following problem. We need to write a method that sums the numbers from some minimum number to a maximum number. That means the header for our method looks like this. In the method body, we need to write the code for our algorithm, or series of steps, that solves this problem. And there's many algorithms that would work here. We just need to find one that not only works, but also is easy to understand and executes quickly and efficiently on the computer. You can arrive at one possible solution by asking yourself the following question. Can I solve this problem by repeatedly doing some operation? In this case, we can solve the problem by repeating an operation. By repeatedly adding a larger and larger number to the sum, we'll eventually arrive at the total sum. We'll do that using a for loop. We call this an iterative algorithm because it solves the problem by repeating an operation. Let's test it out. Good, so that's one solution to this problem. And it's a good one too, because it's easy to understand how it works, and it gets the job done quickly and efficiently. Sometimes, however, it's difficult to think of an iterative solution to a problem like this. That doesn't mean one doesn't exist. It may just be that you, the programmer, can't think of one. Or maybe you can think of an iterative solution, but the code for it is a bit convoluted and hard to understand. Fortunately, there's another way to attack such problems, using a process called recursion. Recursion is a process in which the overall problem is solved by solving a series of similar but increasingly simple problems. That sounds complicated, but it's really not. Here's how to find a recursive solution to our problem. First, we just need to think about the overall problem. In our example, adding the numbers 4 to 7, and ask ourselves, can we solve that problem by solving a similar but smaller problem? In this case, we can. To find the sum of the numbers from 4 to 7, we can find the sum of the numbers from 5 to 7 and then just add 4 to it. Notice that summing the numbers from 5 to 7 is indeed similar to, but slightly simpler than adding the numbers from 4 to 7. And don't worry that if we don't know how to add the numbers from 4 to 7, we also don't know how to add the numbers from 5 to 7. All we're looking to do is break the original problem down into a slightly smaller problem, and we did just that. Let's keep going here. To sum the numbers from 5 to 7, we can sum the numbers from 6 to 7 and add 5 to it. Again, this breaks down a larger problem into a slightly smaller problem. And then to sum the numbers between 6 and 7, we can sum the numbers between 7 and 7 and add 6 to it. And the sum of all the numbers between 7 and 7 is just 7. Notice that by breaking our original problem into smaller and smaller problems, we eventually arrived at a problem that was entirely trivial to solve. That's how all recursive algorithms work. Now let's delete our iterative solution and write the code for this recursive solution. Recursive algorithms should always start by checking for what's called the base case, the case that is trivial to solve. In our method, That's when min and max are the same number. So we'll use an if statement to check for that condition. And if it's true, we'll immediately end the method by returning the sum. When min and max are the same number, the sum of the numbers between them is simply that number. Again, this is called the base case. It's the smallest, easiest problem to solve. When it's reached, the entire algorithm ends. Now let's deal with the non-base cases. Looking here at those cases, you'll notice a distinct pattern. The sum is always the sum of a smaller set of numbers plus min. So if we aren't dealing with a base case, we'll find the sum by calling the sum method on min plus 1 and max, and then add min to it. And that's it. That's a recursive solution to our original problem. Before analyzing this code further, let's just make sure it works. Good. Okay, so let's look at this code a little more closely so we can understand how all recursive methods work. Recursive methods typically possess three properties. First, they have a base case, the case that is easy to solve and causes the entire algorithm to finish. Second, recursive methods call themselves. This is the part that looks a little strange when you first see it, but it should make sense. To sum a bunch of numbers, we are first summing a slightly smaller bunch of numbers. Third, they have to make some progress towards the base case, or else they may never come to an end, sort of like an infinite loop. In our example, notice that adding 1 to min progresses us towards the base case by moving min and max closer together. And that's it. Those are the three basic elements of any recursive algorithm. Before we go, let's see exactly how this all works for our specific example. First, this line of code executes, calling the sum method and passing 4 and 7 as the two parameters. During that method call, this line of code executes, which means sum is called again, this time with the parameters 5 and 7. This causes the original method call to pause until the new one finishes. That new method call also executes this line of code, calling sum on the parameters 6 and 7, and causing itself to pause. And then the same thing happens once again, this time calling sum on the parameters 7 and 7. During that method call, this base case condition is true, so that method call simply returns a number, in this case 7. Once that method call finishes, the one that invoked it will unpause and also finish, returning the value of 13. And then the method that called that one will unpause and return the value 18. Lastly, our original method call, the one that kick-started this whole process, will unpause and return the value 22. So that's how recursive methods work. Don't worry if you found this analysis a bit confusing. In my next lesson, I'll show you exactly how to analyze any recursive method you may encounter. And that wraps up this lesson on recursion in Java. I'm Andy. Thanks for watching and coding with me today.